Hello students, welcome to my YouTube channel Easy Mathematics. This video is about how to form a differential equation if an equation is given. So for any given equation, if you want to form the differential equation, then we should look at which steps we should follow. So for an example, a general example at first I am starting with. So let a function is given which is a function of x and y, where one of these two variable is dependent and another one is the independent variable, and c1, c2 up to cn, these are the n constants are involved in this equation. So this one, if is equals to 0 is the equation, and in this equation for we are going to differential equation. So how to form the differential equation for this primitive? So to obtain this one, we should follow the three steps. So in the first step, what to do? We differentiate the given function with respect to the independent variable x. X, if we assume that it is the independent variable in the given primitive, then with respect to x, we should differentiate the given function first. Now differentiate the equation as many times as the number of arbitrary constants given in the equation. It is a very important step. I'm just telling you in the first step that you should differentiate the given function for one with respect to x. But how many times we should differentiate, that is decided by the number of arbitrary constants involved in that equation. So this is the second step. If in this given equation as n number of constants are involved, so we should take the derivative of this one n number of times. So first derivative for we get the one equation, second time when we do the derivative, then we get one more equation. In this way we shall find out n number of more equations. Now in the third step, we should eliminate the constant c1, c2, cn. That means this all n constant we should eliminate from all those equations to get the required differential equation. So the steps are very simple. Initially, whatever the equation is given, with that we should take the derivative with the independent variable, that is with respect to the independent variable, and this derivative we should continue up to the number of arbitrary constants involved over there, and in that process we shall generate some equations. In fact, the given equations, and if n number of variables are there, then n extra equations we generate. So total n plus 1 equations you shall find out. So using all those equations, we should eliminate the given arbitrary constants to form the differential equation. So with some example, we should verify that how to form a differential equation if a particular primitive or equation is given. So let us start with a very simple and known example. So a straight line, it is given. Everyone know what is the equation of a straight line? Let it is y is equals to mx plus c. So this equation is given and we are supposed to find out the differential equation for this function. Here m and c, m is the slope and c is a constant. These two things are given, and the given question n, you shall provided that m is arbitrary constant. When m is arbitrary constant, that time what should be its differential equation? If c is the arbitrary constant, then what should be its differential equation? And when m and c both are arbitrary constant, then what should be its differential equation? So let us do one by one. At first, this one is your given equation, and when m is the only arbitrary constant, that time what should be the differential equation? So what to do? Only one arbitrary constant is there, so that we should do only one time derivative with respect to x. So after doing the derivative, we shall find out dy by dx is equals to m. Now this is the arbitrary constant which we should eliminate in between 1 and 2, and if we eliminate these two, we should substitute instead of m this dy dx, and after substitution we shall find out this one. So which is our required differential equation? It is so very simple. Now the second case, that means when c is the arbitrary constant. If c is the arbitrary constant, then what to do? We just simply again take the derivative with respect to x, and after derivative we shall find out dy by dx is equals to m. Just look, it is independent of c, that means c is already eliminated over here, so that we can say this is dy by dx is equals to m itself is the required differential equation. So now it is the third case. In the third case, in y is equals to mx plus c, m and c both are the arbitrary constant. As two arbitrary constants are there, that's so why we have to differentiate twice. So first time derivative we know it is dy by dx is equals to m, and when we do the second order derivative, then it is d square y by dx square is equals to 0. So look, in this equation we will have it is independent of m and c both, so that we can say this one is the differential equation. Here not required to eliminate c and m because it is already eliminated from here. So this is your required differential equation. Let us do one more example. So in this example, the given equation is y is equals to ax plus b, where a and b both are the arbitrary constants. So what should be the differential equation of this one? So for this, as there are two arbitrary constants, so we should take the 2 times derivative. So now first time derivative when we will do, then we shall find out dy by dx is equals to minus of a by x square. So now we should take the second order derivative. So for the second order derivative, we just do slight adjustment. This adjustment is x square we multiply here, so that the equation becomes x square into dy dx is equals to minus of a. Now if we differentiate, then it is the uv type function, that means two functions are there. So first function derivative of second plus second function derivative of first. In this way if we do, then we shall find out this one, and here no arbitrary constants are involved. So this is our required differential equation. Let us do one more example. So find the order and degree of the differential equation of the family of curves. This one. So this one is a given curve. For that, at first we should find out the differential equation. After getting the differential equation, we should say what should be the order and degree of that differential equation. So at first we should find out the differential equation. So for that, at first we should check how many arbitrary constants are there. So only one arbitrary constant is given. So we should take the first order derivative and only one time with respect to x. So if we do that, then the derivative we shall find out y into dy dx is equals to c. Now this we should eliminate c from the given equation and the first order derivative equation. So after this elimination, we shall find out y square is equals to 2y dy dx into x plus root over of y into dy dx. We just simply substitute instead of c the y dy dx in the equation number 1. So after this substitution and simplification, we shall find out, just look at this simplification here. So after the simplification, we shall find out the differential equation as 4y into dy dx its whole cube minus 4x square dy dx its whole square plus 4xy into dy dx minus y square is equals to 0. So now, can you tell me what should be the order and the degree for this differential equation? I hope you can, because in our previous video we come to know how to find out the order and the degree of a differential equation. So I am not going to do the answer for you, and I am expecting the answer from you peoples only. So that I am waiting for your reply. Just write your answer for this question in the comment box, and if you are giving the wrong answer, I shall give you the explanation again. But I recommend to go for the previous video if you have any kind of doubt to calculate the order and the degree of a differential equation. So I hope you understand how to form the differential equation if a primitive or the function is given. So have a nice day. Thank you all.